Hello, geometry students. This is Mr. Ousley speaking to you from the classroom. Empty as it may be, I'm going to go over some examples that should be very helpful for you as you tackle, a handful of problems tonight. So I'm going to get to it. We're working from the packet that's attached in Google Classroom. It is, I would pause the video and make sure you're on track with me as I'm going through this explanation. It is page 132 in the packet that's attached digitally, and we're working through example 2. So pause it, find the video, or find the spot. All right, let's get to it. So this is a basic problem that has a large triangle split into two smaller triangles. And they're basically saying we've got some degree measures, but we need to find out what x, y, and z are. So really all it's asking you to do is apply the triangle theorem, the triangle sum theorem, which basically says that all the angles in a triangle have to add up to 180 degrees. So it's kind of like saying everybody in this triangle has to add up to 180, all the angles, yeah? And then everybody in this smaller triangle, all of their angles adds up to 180. But then also in the larger triangle itself, we have to have this plus this whole thing must equal 180. So here's what we can do. If we're just looking at this triangle that I outlined here, you can say that 65 degrees plus 39 degrees plus x degrees should equal 180. And then using your skills for solving equations, it's really not that big of a deal. You take 65 plus 39, which should give you, 90 plus 14, 104. And then we subtract 104 from both sides. Let's see, 180 minus 100 would be 80. Then take away 4 more, it'd be 76. So we know that this is 76 degrees. Now here's the thing. If we know that this angle is 76 degrees, and we have y on the other side of that, they actually form what's called a linear pair. All right? Linear pairs are supplementary, which means they add up to 180 degrees. So, this, which makes sense, right? Because these, if I kind of separated this from the diagram, this is my 76 degree angle. This is my, quote, y degree angle. This here is 180 degrees. So what plus 76 gives you 180? Simple subtraction again. 76 from both sides, take it away, and you get y is equal to 104. Now here's an interesting theorem that comes from this result is, did you guys notice that 104 showed up over here, and then it ended up showing up over here as well? Well, that's because whenever you have an angle that's just outside of two known ones, these two will always add up to the one on the outside. You can always use what we just did with the triangle sum, like they all add up to 180, and then you can use supplementary angles to find that last one. But just, that might show up a little bit in the future. So now, we've got 104 right here. We have z in the corner. So this triangle here has 21 degrees. I'm sorry, I think it's 2. Okay, there we go. So this right here, 21 plus 104 plus z equals 180. So a shortcut for that is you can say, take 180, subtract the 104 here, and then subtract the 21. So 180 minus 104 is 76. 76 minus 21 ends up being 55 degrees. So, we got them. 55 is z, 104 is y, x equals 76. Let's check another one out. Let's go to page 135 in your packet. Okay. And then I want you guys to focus on number 8. Okay, so check this one out over here. It's a little bit like the example we just did. We have a triangle here. Where we're given 2 of the 3 angles. So this x degree measure should be pretty basic to solve for. 70 plus 30 equals x. I'm sorry, I totally misspoke there. 70 plus 30 plus x equals 180. All right, let me just make sure you guys can see that. You can't see that. Okay. Sorry, I'm struggling a little bit with the visual. As you can see, every time I step in a certain place, it basically brightens the background behind me. That's kind of rough. Okay. All right, so over here. 70 plus 30 plus x is equal to 180 degrees. We know that from the triangle sum. Pretty basic. X equals 80. So that's 80 degrees. Now, y has a different relationship with the 80 degree angle. The y value is across from the 80 degree value. And if you remember, this is all review stuff from chapter 3. If you remember, these across from each other are called vertical angles. And what's special about vertical angles? They're congruent. So y also is 80 degrees. So keep this in mind. You're going to get some that are supplementary with one another and some that are vertical in that relationship with one another. So don't just blindly subtract from 180 every single time. And don't just blindly say, oh, I see 80 degrees, then that means the other one has to be 80 degrees. Just make sure you're recognizing the relationship between vertical angles and supplementary angles. When are 2 things congruent, and when do 2 things add up to 180 degrees? Let's check out number 27 on this same page. So it gives us, I'm going to redraw this, rotate it a little bit so we can see it better. Hopefully that's okay with you guys. So the 13 degree angle we're talking about is right here. This is 2. You know what? I want to give that a variable name. Let's call it x. And then this outside angle here is 128.5 degrees. So what this should tell you guys is, I know that if this is 128.5 degrees, then this angle right here is going to be 180 minus 128.5 degrees. Not the x angle itself. It's this other unknown right here. So then 180, what we can do is we can just say, what's 180 minus 120? Okay, that's 60. What's 60 minus 8? 52. Take a half more. It's 51 and a half. So we've got 2 out of the 3 angles in this triangle. All right? So I'm going to kind of just erase this now and say, I know that this one right here is 51.5 degrees. I know that this one right here is 13 degrees. I can figure out x because they all add up to 180. Or I can take 180 and subtract 13, which would give me 167, and then subtract the 51.5 from there. So 167 minus 50 would be 117, take away 1, 116, take away a half, 115 and a half. Okay, let's see here. How about we go to page 136 and do number 31? This will be the last one. Okay, so hopefully these types of examples are looking very familiar. We've got a triangle, we've got a triangle, we've got a triangle. Hey, we've got another triangle too. Okay, so all we got to do is keep using that triangle sum. That whole idea that this plus this plus this is 180. This plus this plus this is 180. This plus this plus this is 180. So now, I wanted to highlight an example that was a little trickier. This little arc right here, if you'll recall, represents 2 things that are congruent. So if this one's x degrees, and that means that this one's x degrees also. So all you're doing is you're saying, let's see, find the values of the variables and then the measures of the angles. So I'm trying to figure out what x equals. So I just take x plus 75. That's equal to 180. So x plus x is 2x. I can also subtract 75 from both sides on that same step. 180 minus 75 is 105. To solve that equation, I divide by 2. So my answer is x is equal to 52 and a half. Now it also says find the measures of the angles. So that means that this is 52 and a half degrees because it was just x. This is also 52 and a half degrees, and we already know that that's 75. I'm going to ask you guys to do a couple of these, so it's pretty much the same idea, but maybe a little different work that you're doing. Classify each triangle by its angles. If you remember, angles can be classified by, you know what, I'm going to hold off on that because I'm running out of time in this video. I kind of put a 15-minute max at it. So I will put what problems you're expected to do in Google Classroom. Okay? If you have any questions, please email me. All right, guys. Miss seeing you every day. Hope you guys are doing well. Adios.